Get off the boat, keeping this soft like a me. Go to my link, coke in the sink.
How's it going, guys?
Chopping that work like karate. Serving the new Maserati.
How's it going, guys? Today, no.
That's a whole lot of new money. Session and hide it from 12. Moving the squares in them.
How's it going, guys? Today, I want to go over a problem called reverse linked list. Most people are probably going to think that this is like an easy problem. It says easy, I know it does. Again, it's kind of relative, but I think this is a good problem to go over specifically because linked lists, as like engineers, I feel like most people think they're really useless. We don't use them a lot of times, but they are questions that come up during interviews, and I think it'd be a real shame if like something that's supposed to be easy is given to you on an interview and then you didn't really prepare for it and all of a sudden you don't know how to do it. So linked list questions are questions that come up. They're not super relevant, I feel. Like I haven't had to use them that often, if at all, but the good thing about linked lists is there's only really like a handful of questions that you might get. So once you know them, you're pretty much set. So let's get into this problem. So this one just says reverse linked list. It's pretty simple in terms of what we have to do, right? So we're given a linked list, 1, 2, 3, 4, 5 null, and we have to return it reverse, so 5, 4, 3, 2, 1 null. So problem statement's pretty simple. I think the best way to do this is throw everything into a stack. So if we traverse the entire list, so 1, put it in the stack, 2, put it in the stack, 3, 4, 5, our stack now contains the list reverse. So once it does, we can just iterate through the stack, right? And then pop everything out of the stack, adding it to a new list, and then our list is reversed. So pretty simple. I think the runtime is pretty fine. The space complexity is like a little heavy because it's O of n. But so the runtime's O of n and the space complexity is O of n, meaning n is just the number of nodes we have in the list. So let's do that solution and then we can talk about it. So first thing we want is the stack we said. So our stack is going to hold list nodes. We'll call it stack, new stack, list node. Whoops. Okay, so we have a stack. So now we need to traverse the list, putting everything into the stack, right? So we'll just say while head is not equal to null, meaning we haven't gotten to the end of the list. We will say stack.push head, and then we want to set head equal to head.next. So the next iteration in the loop, we're not going to process the same node, and we'll actually, terminate our loop eventually. So now once we've gotten through the first loop, we have a stack, right? So now all we need to do is pick things out of the stack one by one, adding them to a new list. So we need something to add it to, right? So let's make a dummy node. We can make a list node called dummy, set it to a new list node, and then we'll just give a random value. I feel like -1 is indicative that like we don't really need it, kind of, so I just set it to -1. And now we actually have a list node that we're not using, right? So head is currently at the end of our list because this loop terminated, right? So head should be pointing to null now. And we can actually reuse that variable to keep track of the node that we're on in our stack. So we'll just say head is going to equal, or not the node that we're in our stack, but where we are in our new list. So we'll say head equals dummy. So in other words, head is going to point to the beginning of our new list, which currently is our dummy node. And now we'll just say, while our stack is not empty, we still have some nodes to add to our new list, right? So let's process them. So we'll say list node current, meaning the current node that we're on in the stack is equal to stack.pop. So now we have a node to process, and now we said all we have to do is add it to our list, right? So we'll say head.next equals new list node current.val. Okay, so now we, again, just took a node from our stack. So we plucked it out of the stack, right? Stack.pop. And now we're setting the next reference in our new list to the node that we just took out of the stack, its value. Cool, so now all we have to do is say head equals head.next, so that the next iteration, right, if we just added this node, we want to jump here and add this next thing. Or sorry, if we just added this node, our head would have been here, right? Because we set head.next equal to that new node, and now we're jumping to the next node so we can add the next one on the next iteration. Hopefully that made sense. Cool, so now once this loop terminates, everything in dummy, or dummy is the reference to our new list, right? But dummy is actually just the beginning of it. So all we have to return is everything following it. So we could just say return dummy.next. So let's run this and make sure it works. Awesome, and it looks like it does. So this is how to solve reverse linked list in Java. Some people are probably going to talk about how this isn't super efficient, you're using extra memory, so I'm actually going to challenge you guys now to figure out how you can do this faster. I'm going to give you a hint, and basically the hint is you don't need an entire stack. So you can reverse this using constant memory, so try and see if you could do that. Okay, this is how to reverse a linked list in Java. I hope this is helpful, guys. I will see you next time. Also, at the end of the video I'm mentioning this, but this is asked by a lot of companies. Microsoft, Facebook, Apple, list goes on and on. So good luck doing this. I encourage you to try and optimize it. Leave any of your questions or optimizations in the comments, and I will talk to you guys next time.
That's a whole lot of new money. Session that had it from 12. Moving them squares and them bills. Serving the raw as a yeah. Beating that China like who's a kitchen. Whipping that fishing for a king. Fucking no syrup, I'm rolling up hay. Made myself a boss in the plug. Either way you